Good morning, my YouTube viewers. It is Crystal here. I'm here this morning to give you a code review. What we're going to talk about is we're going to talk about a random walk, which is an algorithm that you can use to make predictions. And basically, the reason why I decided to do this code review is because I was studying a video on time series analysis and forecasting by a Dr. Sarkar, and he was using R. And in the R programming language, they do actually have a random walk with drift, and it also covers STL, and it can be used to make predictions. But I'm not able to find any random walk for Python. I found some algorithms where people have written their own code, but it was just a generic random walk. It wasn't a random walk to make predictions. So I thought, well, it would be a good idea that if R has an algorithm for random walk, maybe I'll make a random walk in Python. So I did the random walk, and we'll go ahead and go over the code. And you can see the random walk for yourself. We did it with the data set to make a prediction. And then after we've gone over the code and you've seen the data and you've seen the prediction, you might understand why Python doesn't have a random walk algorithms to make predictions. But in R, it was a random walk with drift, and then it was talking about an STL component. And my programming is not that good to do a random walk with drift or an STL component. I would have to actually find some code and see if I could modify the code. But we'll just start out with a really easy, basic random walk. And then if I find some code for random walk with drift, then I'll do that as well. So I've made this program. What we're going to be using is the tractor sales data set, and I got the tractor sales data set off of GitHub. And I will say I have a GitHub account, but I haven't used it in a long time because the place where I do business, GitHub is banned, and so I just haven't been using GitHub since it's been banned in the place I do business. But we're using someone else's GitHub account to do the tractor sales CSV. So the first thing we did was we imported our libraries. We're importing NumPy as MP, and that allows you to do numerical computations and also create NumPy arrays. We import Pandas as PD, and that enables you to create a data frame, and it enables you to do data processing. We're importing Matplotlib as PLT. That's a graphics database, and that enables you to plot your data points onto a graph. We're importing Seaborn as SNS, and that's a more sophisticated graphics program written on the back of Matplotlib. Enables you to do like statistics with your graphics. And we're going to import math, which enables you to do some math calculations. So the first thing we're going to do after we've imported our libraries is we're going to use Pandas to read the file. And we're reading the file from someone's GitHub account. And then we're going to define our columns. Our data columns are month, year, which is the date, and tractor sold. And then you can see the data frame that's been created. We want to do an info to find out what kind of data frame it is. And then so the month year is an object and the tractor sold is an integer. So now we're going to create a dates. So dates equals pd.date range start 2003-0101. Frequency equals ms. Periods equals len data days. So now we've got dates using the Pandas data frame. So we're going to plot our graph. So plot fig size equals 15.3. Plot PLT plot dates. data.tractor sold. So that enables you to plot the sales over the years. And then PLT-Y label equals number of tractors sold. PLT dot title is number of tractors sold. And then we're going to show it, PLT dot show. So you can see that this is the first graph that we have made. And you can see that the overall the numbers of tractors are increasing. So what we want to do now is we want to break the graph up between the train set and the test set. So test equals 120 because we're going to we're going to train 10 years of data. And so features equals 1 year and tractors sold. X train equals data features colon up to test size. X test equals data features test size to the end. So we're going to plot the graph of 15.3. That's the size of it. PLT.plot dates to the colon up to the test size, so that's your train. And it's data tractor sold colon up to the test size, that's your label, and that's your training set. And then the next one is PLT.plot dates to the test size colon, and then date.tractor sold to the test size colon, and label equals testing set, and color equals orange. PLT X label is date. PLT Y label is number of tractors sold. PLT title is tractor sales train and test set. And then we have a legend, and then we're going to show it. So now you can see it's the same graph, but it's broken out into training and testing sets. Now what we're going to do is we're going to do the random forest walk. So def random walk 1D, so this is a one-dimensional walk. X equals 0. Y equals X underscore test dot tractor sold dot ilock 0. X position equals 0. Y position equals Y. And for I in range 0 to N. Step equals NP random dot uniform 0, 1. Print step, so we don't have to have print step anymore. I just wasn't sure what was going on. So I put a print step in there so I could see it. If step is less than 0.5, X equals X plus 1. Y equals Y plus 60. If step greater than 0.5, X equals X plus 1. Y equals Y minus 60. And then if Y is less than 0, Y equals 0. Because when you're determining sales, you can't have a number less than 0 if you just sell 0. That is, unless they have returns. So I suppose I could have left the Y is less than 0 out, because if somebody returns a tractor, then that's going to be reflected as a negative sale. But we'll just leave it as 0 because this is a very simple algorithm and we're not going to get involved in returns. X position dot append X, Y position dot append Y. Return X position, Y position. And so now we run the program, or run the function. Randwalk equals randwalk 1D. and it's going to be the length of X test is how long it's going to run it for. And now we're going to plot it. PLT.plot randwalk 0, randwalk 1, R. Label equals randwalk 1D, and PLT title 1D random walks, PLT show. So this is your random walk for 24 steps. But what happened is, don't ask me why, but the first step is the first step. They give the first step as being the number of the first step in the test file, and obviously we don't want that. We don't want the first step being the first step of the test file. So we're going to say y hat equals y hat 1 colon. So what that does is that snips off the first step, because you don't want the first step being the first step of X test. That sort of like, it's not a good prediction if it's the same. And then I tested this program several times and it turned out to be the same every time. So what we're doing is we're just snipping off the first the first step. So we're going to calculate errors. MSE equals NP dot square NP subtract X test tractor sold Y hat 0 mean, print MSE, and then RMSE equals math dot square root MSE, and print that. So your MSE is 69,806, and then your RMSE is 264. So those are your errors. So now we're going to compare the predictions to the true values. So you've got 454 is your actual, and your predicted is 394, and then it goes all the way to 24 steps to give you a 904 is your predicted. So you can compare the actual values to the predicted values. And then your dates are, we're going to set this up to where we've got to make a month and a year for your dates. So you can see that we use string functions in order to accomplish that. Data.mon equals data mon year dot string colon to 3. So that means it's going to take the first 3 characters. Data year equals data mon year string starting at 4 to the end. So that means we're going to take the last 2 characters. Data.drop mon year axis equals 1 in place equals true and data. So now you can see it's broken down into month and year. So what we're doing now is we're adding 20 to the year. So data mon year equals data mon plus 20 plus data year data. So now you can see that now we have a proper date, Jan 2003. So now we're going to use Pandas to convert the date to date time. Data mon year equals PD to date time data mon year data. So you can see that. Now we've got data TS equals data. Data TS dot timestamp equals PD to date time data month year format day month year. Data TS dot index equals data TS dot timestamp. Data TS drop mon axis equals 1 in place equals true. Data TS equals data ts.resample_m_mean data ts. So now you've got the month and the year as being the index, and the tractor sold as being the number. So now we've only got like one column of data in this time series data frame. Now we're going to split the dates up. Xtrain data ts.log 2003-01-01 to 2012-12-31 to xvalid equals data ts.log 2013-01-01 to 2014-12-31. And so we say y hat equals pd data frame y hat. So we've used Pandas to make a data frame. And y hat dot index equals xvalid index y hat. So now the index of our y hat data frame is the same as the index of xvalid, and it's the index is a time. So now what we're going to do is we're going to plot the graph. Going to plot a random walk. dd equals np dot as array xtrain tractor sold. PLT figure size 4:6. You can make the figure size bigger if you wanted to, but I wanted the figures to be small so it could fit on the page, fit on the screen. PLT.plot xtrain index, xtrain tractor sold, labels equals xtrain. PLT.plot xvalid.index, xvalid tractor sold, label equals xvalid. PLD plot y hat index, y hat 0, label equals random walk forecast. And PLT.legend, and it says log equals best. PLT.title, random walk forecast, and PLT.show. So now we've got a graph of the train set, the test set, and the forecast. So you can see your random forest forecast. In this instance, it's going up. But what we can do is we can run it again. And then when we run it again, you'll see that it's going to change. So that's your random forest now. Because every time you run it, it's going to change. Or random walk, sorry. It says random forest, but it was random walk. But every time you run it, it's going to change. So there's your random walk now. So basically, maybe that's why they don't have a random walk in Python. And maybe that's why they don't have a random walk in stats models. But what I'm going to do is I'm going to look for the code for a random walk with drift and see if that improves this prediction. But that's prediction now. And then so R does have a random walk with drift, and then it has an STL component in it. But Python, I haven't seen a random walk, and I've looked for it. So I had to make my own. But maybe I'll try a random walk with drift and see if that improves the prediction. So you can see. And every time you rerun it, you're going to have a different random walk. And that's what random walk is all about. So I'm going to go ahead and conclude this video because I've been talking almost 20 minutes just on random walk. I would like to thank my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. I do think that there's not a lot written about random walk on a data set, so I do think that this is a good video to like, subscribe, and share. And thank you so much for watching this video. I will look forward to making more videos for you in the future, and I'll look for the code for random walk with drift and see if I can find it.